This videoscribe covers OCR AS specification 1.2.1 electron structure. Ionisation energies. Data from ionisation energies of atoms gives us important information about energy levels and the electron configurations of atoms. For an atom to be ionised, an electron has to be completely removed from the atom. We can do this by bombarding the atom with high-energy electrons, which removes one of the outermost electrons of an atom. This is an endothermic process, as it requires energy. Atoms must be in the gaseous state so that they are isolated from other attractions to allow all the energy to be used in removing an electron. The definition of the first ionisation energy is the energy required to remove one electron from each atom in 1 mole of gaseous atoms to form 1 mole of gaseous +1 ions. The equation for the first ionisation energy of sodium is, and the first ionisation energy is +494 kilojoules per mole. Note that ionisation energy is measured in kilojoules per mole. So what does this mean? It means it's the energy required to remove 1 electron from each atom in 1 mole of gaseous sodium atoms to form 1 mole of gaseous sodium ions. The equation for the first ionisation energy of chlorine is, and the energy required to do this is +1260 kilojoules per mole. Notice that the first ionisation energy of chlorine is much higher than sodium. Every atom has its own distinctive first ionisation energy, which depends on 1. The distance of the outermost electron from the nucleus, 2. Electron shielding. The inner shells of electrons repel the outer shell electron. The more inner shells, the more shielding. And 3. The size of the nuclear charge, i.e. the number of protons. The more protons there are, the greater the attractive force on the outer electron. Let's look at the trends in the first ionisation energies of group 1. As we go down group 1, the first ionisation energy is decreasing, as although the nuclear charge is increasing, the distance of the outermost electron from the nucleus is increasing. Plus, there is more electron shielding as you go down the group, as there are more shells, so the outer electron is easier to lose. As we go across period 2, the general trend for the first ionisation energy is it increases across the period. Shielding is the same, and the distance from the nucleus is the same, as the electrons are being placed in the same energy level. But nuclear charge is increasing, so more energy is needed to remove the outer electron. For more video scribes, visit www.icanlearnto.com.